Hello, welcome to everyone in this video. This is the part 1 of the solution of nuclear and particle physics of DSE-B-1 paper for semester 5 under University of Calcutta of the question 2021. In this part, we want to discuss about question number 1 of A to G. You can see this is the total question paper and this is question number 1. You need to solve this question 1, that is out of 7 you need to solve question 5 question, and in question 2 there is 5 question. Out of 5 question you need to solve 3 question, and after that you can see here written here, and any 4 from the rest one, that is 3 4 5 6 7 8. After out of 6 question you need to solve 3 question, 4 question, right? Out of you need to solve 4 questions. So you can see this is the total question of this year 2021 asked, and you need to solve this question yourself. After that you can go through the video to watch the solution of this question. Okay, so you can see this is the question 3 4, this is 4 5 6, and this is 7, and this is 8 finally. So let's start with question number 1, A to G. Okay, first question says, why does the binding energy per nuclei, A is the number of nuclei in the nucleus, drop from its average value both for lighter as well as heavier nuclei? If you remember, the binding energy per nuclei versus nuclei graph is like that. For very low lighter nuclei, this binding energy per nuclei is lower. In case of higher, this is also lower. In the mid region, this is the average value. And you know, if the binding energy of nucleus is higher, then it's stable, because if binding energy is high, then you need to require more energy to separate out the nuclei, right? So if binding energy high, that's mean you need to more energy to separate out that nuclei. So this is the more stable. So this region, in this region the nuclei are more stable. This is not stable, this is not also stable. So why these are to fall, you need to know. Actually, in the lower region, the mass difference is very low, because the number of particles is low. That's why the mass defect. What is the mass defect? Mass defect is the mass of the individual nuclei. That is, you have to some proton and some neutron, and you know the mass of the proton and the neutron. If you added them, you will be get the total mass of individual nuclei. And if you taking the mass of the nucleus, that is the formed by the neutron and the proton, that is the mass of nuclei is different. So this difference is known as the mass defect. In case of the lower mass number, since there is a number of particle, that is the constituent, that is the proton or neutron is less, that's why the mass number, that is the mass defect also less. That's why the mass defect is less, means the binding energy per nuclei is also less, because the binding energy is nothing but the mass defect converted into energy by this law. Energy equals to mass defect into the c square, where c is the speed of the light. From the relativity theory of Einstein, you know the energy can be obtained from the mass with the relation E equals to mc square, right? So you can say that is the mass defect is lower for this lower or lighter nucleus. That's why the binding energy is less. In case of higher nuclei, there is a repulsive force of the protons, of repulsive Coulomb force between the proton, as the very large number of nuclei obtain a large radius, that is the out of the range of the strong force. Okay, you know why the protons are accumulated within the nucleus where they are repelled to each other. You know, this is two positive charged proton can repel to each other due to Coulomb force, but they are accumulated in a small region due to the strong force which is independent on the charge. But when the nucleus size is large, then what happens? Then due to the range is beyond the strong force range, the Coulomb force are activated. That's why this Coulomb force makes the repulsion between the protons, which makes the are unstable. That's why in case of lighter element, this is unstable and this is also unstable. That's why these two are false. fall, that's mean binding energy is less. That's mean you can easily separate out the constituent by the low amount of energy, right? I think clear about all things, and you need to write down in a easy manner. Next question. See, find the Q value of the following reaction, right? Quiescent value or the Q energy. This is the lithium and hydrogen is combined into two alpha particle or helium. The mass are given, atomic mass are given like here. So you know the Q energy is nothing but that is the mass minus mass into c square, and if you difference into the atomic mass unit, so you need to multiply 931 MeV. So if you just taking the mass of the lithium and hydrogen minus 2 into that one, you will easily find out this 17.338 MeV. You can take 931.5 also, you can check this one. Now the next question says, can this nuclear reaction be produced by protons accelerated to an energy as low as 0.15 MeV? So you can see the Q value of this reaction. That's mean for reaction you need to require this amount of energy. Is there is a possibility to make this reaction with this amount of energy 0.15 MeV? Yes, this can be possible because of the quantum mechanical tunneling, right? You know the barrier of nucleus is higher than the energy of alpha particle which are ejected from the nucleus. How this is possible? This is possible due to the quantum mechanical tunneling. You know from the quantum mechanics, that is quantum mechanical tunneling says like that, if there is a boundary like that and the energy of the particle is like that, so it can penetrate with the function like that. Okay, so its energy will be reduced but it can penetrate. Classically it is not possible, but quantum mechanically it is possible. And here also this reaction also possible due to the quantum mechanical tunneling effect. So this amount of energy also can be possible by this reaction. Next question. Next question says, the amplitude of the RF voltage applied in a proton linear oscillator. You know in the linear oscillator the are alternating voltages are applied here. You can see these are connected in the one terminal of the voltage. This is AC voltage like that. So alternating voltages are given here, and this alternating voltage are frequency are matches to like that. When they are from that one to that one, electric field also there that direction, but when this reach at that point the electric field direction again reversed. Suppose this is positive terminal, this is positive terminal, this is negative, so electric field this one, but when this is comes here, this needs to change into negative, this is change into negative, this is change into positive, so again this is forward. So this electric field, when this jump from one tube to another tube, electric field along that direction such that its speed will be increased, accelerated. That's why it is called accelerator. Okay, so this voltage will be given, voltage will be like that, and frequency is this one. So this frequency must be matches with this length of the rod such that you can see the speed will be increased. So this speed will increase, the length will be the increased such that the time required will be matches with this frequency. Okay, so you can see here this Vn, that is speed of this particle, will be that one, and this derivation I think we will be discuss in the theoretical class. So this can be easily write down here. So you just put down this formula, that is ln equals to 1 by 2f, ln equals to 1 by 2f root under 2n q v0 by m. Okay, I think there is a mistake. Yes, yes, this is a mistake, this 2 is here, so just correct this one. This 2 is here, so what happened, there is 2 and this 2 is not here. So actually we need to multiply by root 2 and divided by, so we actually divided by root 2, but we need to multiply by, that is you need to multiply by 2. Okay, So this is 4, 6, 9, this one. Clear? So this will be like that. I think you can check this one. This formula is written is in the wrong pattern. Okay, go to the next question. Next question says, using the single particle cell model, calculate the spin and parity of K 1939. Okay, so here the number of proton is 19 and number of neutron is 20. So this number of proton in the cell model can be written as 1 is half 2, that is the top proton, 1 p 3 by 2 4, 1 p. You know the sequence in this manner in the cell model. I think you know that. In theoretical class we will be discussing. So this is 1p half to 1d 5 by 2 6 2 is this one. So if you sum this one you will be get 19, and if you sum this one you will 20. So in neutron there is a pair, there is no unpair, so there is no contribution in spin and parity. There is a single unpair which is situated in d3 by 2. So this d, that's mean l2, l is 2, that is parity is even, and this j value is 3 by 2. So ground state spin parity will be 3 by 2 plus 3 by 2 is spin and plus is the parity. Next question, what is the minimum velocity of a charged particle so that it's produce Cherenkov radiation while passing through a dielectric medium of radius 1.5? What will be the actually Cherenkov radiation? When the particle velocity is such a way, it's higher than the speed of light within that medium. You need to remember, the speed of any particle cannot be excess with the speed of light in free space. It is impossible from the theory of relativity, that is, no particle can exceed the velocity above this amount of velocity, but the particle velocity can be above compared to the velocity of light within that medium. Okay, so within that medium the speed of light can be speed of particle can be larger than the speed of light within that medium, but it cannot exceed that one. Okay, so here happen what happen in case of Cherenkov radiation. When a charged particle are emitted, it's radiate. So this radiation speed, that is the speed of the light, is less than the speed of this particle. Then what happens, there is a cone format and there is a superposition where they are form a cone with a high intensity at these two region. There is supersonic plane, you know, that is the actually Cherenkov radiation for that is for sound, and this is for the emission, that is light, electromagnetic wave. So along that direction the lights are passing through this one, and the light velocity within that medium is c by n. V is c by n into t, and this is the velocity of particle. So along that one, so from this is perpendicular, this is spherical wave front from here. So from this one you can see that is cos theta equals to base by hypotenuse. So from here you will be obtain this one. So velocity weekly this one. For minimum velocity, when this v is minimum, the cos theta will be maximum. So this is 1 if you put, so v equal to c by n. Okay, so this gives you that one. Okay, so this is the speed of the particle for that the minimum velocity. This minimum velocity required performing for Cherenkov radiation. Next one, what information about nuclear force do you get from the study of the binding energy difference of mirror nuclei? What do you mean by mirror nuclei? Actually, if there is two nucleus, there is A and Z and A, and there is another, that is this will be the Z1, but this is A. Here the number of proton and number of nuclei is interchanged, but because that is Z plus Z1 equals to A, such that. So this number of proton and number of neutron are interchanged such that this A is same. So this is called mirror nuclei. For mirror nuclei, you can see this, the energy difference, binding energy difference is 0. That's mean the actually this is depends on A. So number of proton and number of neutron are interchanged, but the binding energy is the same. That is, the binding energy is independent on the nature of particle, whether this is proton or neutron. That is the strong conclusion obtained from this experiment. That is, the strong force which is exerted within the nucleus is independent on the charge, right? So you can easily say from this experiment that the binding energy of the mirror nucleus is the same. That's mean the binding energy of nucleus is independent of the charge, whether the proton or the neutron. It's actually taken as the nuclei. Okay, so number of nuclei is actually taken account to finding the binding energy. So strong force is independent on the charge. This is the conclusion. Next question. Explain in terms of the Quark model why the meson with charge q equal to -1 and strangeness s equal to +1 is not observed. Okay. Understand. This is, you need to know about the quarks with the value of strangeness number and the charge number. Okay. You know the strangeness number is -1 for strange particle. If you know about the chart of the quark, that is, you know the charge are the up, down, strange, charm, top, bottom. These are the major 6 quark. There is another lots of quarks are available at that moment, but the major 6 quarks are the strange, charm, before that up, down, after that top, bottom. 6, right? So for that, strangeness is -1 for strange particle and strangeness is +1 for anti-strange particle, S bar. Okay, so strangeness is 1, that means you need to take anti-strange particle. After that, since whose charge is plus 130, but the total charge is minus E, so you need to require another quark such that total charge is -1. How this is possible? If you take a quark with the charge -430 or take two charge with equal -230, or take 4 equal charge with -130, or you can take -230 and another combination also I can write down here, that is, or 2 with -130 and -230. This is the another possibility, but you know there is no quark with the charge -230 or -430, so there is no possibility to account this one and this one. You need to take 4 particle with charge -130. Clear? So there is one particle, that is anti-strange particle, quark particle, and you need to take 4 quark particle with charge -130, and you know -130 charge is for down and the bottom, or you can say anti up, anti up, down, top, bottom, anti top. Okay, but you need to take 4 quark particle and there is one, so there is 5 quark particle, and you know for each quark particle isospin is half. Then what happen? For 5 quark particle, the isospin will cannot be 0. Cannot be 0 because this is 5. Total each quark have spin half. So the combination of 5 spin cannot be 0. But you know for meson this total spin is 0. So this cannot be formed. Right? So with strangeness 1 and charge -1, meson cannot be formed, and this opposite one, that is changes, is -1 and this is +1, also cannot be formed. Okay, actually mesons are formed with 2 quark particle, one is quark and one is anti-quark. Okay, so I think clear. If there is any doubt, you must comment in the comment box. In the upcoming video we will be discussing the more question number 2, I think. So that's it for today. This is all about me. This is my contact detail. You can connect with this Telegram channel. This is my YouTube channel details. Go to this channel. You will get different physics related videos of mathematics. Like this session. If you learn something from this session, share this video to your friends. Either he or she also get benefit from this video. Subscribe this channel if you new in this channel. Those already subscribed, thanks for subscription. Press the bell icon to get notification of upcoming video. So take care. We'll meet on the next video as soon as possible. Thank you.